Welcome back to my course, and today we will start from the fifth module, and let's start from the theoretical background. Lecture 5. This model concerns spatial and attribute queries in ArcGIS. So when you want to set up a GIS application to solve a spatial problem, you start with defining a conceptual model of reality and collecting spatial data. The next logical step involves spatial and tabular operations using the data you collected. You need to analyze, combine, and integrate your dataset, the so-called data handling, to extract the spatial information you need to solve your spatial problem. So, queries are processes that extract information from a GIS by making selections from tabular and spatial datasets. These selections do not change the geometry and attribute information of the datasets. The process do not change the semantic and geometric meaning of the original data. With queries, you can select a set out of the whole dataset. You can discover and analyze new spatial relationships and solve problems when you start asking questions such as where is the closest, what is inside, and what intersects. So, tabular dataset queries. Tabular dataset queries, or in other case attributive queries, retrieve a set of table records. Query condition is based on attributes and their values. When the tabular records are selected to features, both table records and associated features are selected. Selecting features by using a query expression. A query expression is a precise definition of what you want to select. Building a query expression is a powerful way to select features because an expression can include multiple attributes and operators. Remember, for instance, when you make a query expression in Google, you should write correctly, and Google, using a query language, search from its database the information you need. Or for instance, another very famous query expression language is SQL. The expression contains logical operations, Boolean, and, or, etc., and relational. The output of the query expression is therefore true or false. The features for which the query condition is true are selected. The features for which the condition is false are not selected. When you select features, they are highlighted on the view window. Features remain highlighted until you make a different selection, or when you deselect them. When you open the attribute table, you will see that the feature table records for the features you selected are also highlighted. Spatial dataset queries. Spatial data queries select a set by working directly with features without using attributes and query expressions. This means that features are selected based on their distance to a certain location or based on their spatial relationship to other features. In this section, 3 spatial data query methods are discussed: selection by cursor, by graphic, and on basis of spatial relationship. So we will discuss attribute queries, spatial queries, queries by graphic, and the last one is raster data queries. Raster data queries differ from vector data queries. Vector queries allow you to select individual features from a dataset, but you cannot select individual raster cell. When you query a raster, you use a query expression as well as in vector. When you use the attribute value in the query expression, you will select a zone of the raster dataset. The selection will contain all raster cells with the same value. The vector equivalent of this type of selection is the selection of a class. A class is formed by all features with the same attribute value, for instance, buildings in a land use dataset. So selecting and exporting raster cells using the conditional tool. With the con tool, you can select and export raster cells based on a conditional if-else evaluation. This means that a user-defined query expression is evaluated for each cell of the input raster. The output is a new raster dataset. If the evaluated cell values of the input raster are true, then user-defined values are assigned to these cells in the output raster. User-defined values can, in this case, be the original cell value, a constant, or the value from another raster dataset. The cell values that are evaluated as false can be set to a different set of user-defined values. For example, if the cell value in the input raster is greater than 10, then return 1, otherwise return 100. A selection is where the geometry and attribute information do not change. This is the case where the original cell values are saved in the output raster. If the values are saved in the output raster, then not only a selection takes place, but also an operation because the thematic data of the raster changes. A great advantage of the cone tool is that you can retain the original cell value in the output raster. A disadvantage of the cone tool is that you can only use it for discrete rasters. For rasters with a floating data type, continuous raster, so you cannot use a cone tool.